The James Webb Space Telescope, often referred to as Webb or JWST, is a pioneering scientific instrument that has uncovered astonishing details about stars, planets, galaxies, and other intriguing cosmic phenomena, setting new benchmarks for scientific wonder. Webb is celebrated as the esteemed Hubble Space Telescope's successor. People globally are exchanging images or utilizing raw data to create new discoveries. 1 year has elapsed since the formidable Webb Space Telescope presented its inaugural historic image of the universe, astonishing astronomers everywhere with its remarkable clarity. Yet its latest finding is a terrifying depiction of the universe like never before. The discoveries made by the James Webb Space Telescope so far are raising more questions than answers for researchers. Join us as we delve into how the James Webb Space Telescope captures the most daunting image ever recorded in history. The heir to the Hubble telescope has unveiled new insights into star formation, galaxy collisions, and the primordial universe. Just 1 month after the initial images were released, they were breathtaking, showcasing the universe in unparalleled detail. Since then, the volume of discoveries has soared, providing scientists with a vast treasure trove of data. James Webb Space Telescope observations of cosmic tarantulas, record-breaking space haze, stars nearing supernova explosions, and other remarkable celestial objects have been documented. This satellite observatory's advanced technology allows us to look deeper into space than ever before, revealing previously hidden aspects of the cosmos. A new era in astronomy has begun, thanks to these highly detailed images. In celebration of the first year of the James Webb Space Telescope's operation, NASA released an image depicting a small star-forming region in the Rho-Ophiuchi cloud complex. The image shows jets erupting from newborn stars as cosmic dust clouds of various hues collide. Molecular hydrogen constitutes the red dust, and the presence of a circumstellar disk casts a shadow on a few stars, hinting at potential planet formation. Although the image might depict cosmic chaos from the distant past, according to NASA, this stellar nursery is relatively small and tranquil compared to others. Additionally, many of the young stars in this region are about the size of our Sun or even smaller, making it the nearest star-forming region to Earth. This image was captured by the main camera of the observatory, the Webb Space Telescope's near-infrared camera, which captures cosmic images in 2 distinct infrared spectrums simultaneously. Moreover, the Space Telescope has enhanced our understanding of exoplanets, or worlds that orbit stars other than our Sun. James Webb excels at observing large galaxies. The satellite observatory discovered its first exoplanet, LHS 475b, at the beginning of 2023. The planet is 41 light-years away and has a diameter comparable to Earth. According to NASA, James Webb is the only operational telescope capable of classifying the atmosphere of Earth-sized exoplanets. Following that, the James Webb Telescope found evidence of long-gone galaxies that theoretically shouldn't have existed. Eva Swindon from the university and her global astronomical team discovered 6 enormous ancient galaxies, termed universe breakers. They have the potential to radically alter our understanding of space. These colossal galaxies may have formed between 500 to 700 million years after the Big Bang, according to the researchers' findings earlier this year. The telescope's infrared sensors detected them using these instruments, allowing us to glimpse back in time approximately 13.5 billion years, when stars and galaxies were significantly younger. The sheer size of the universe breakers has left scientists baffled. Galaxies in the early universe should have been 10 to 100 times smaller than that. Their calculations suggest that these 6 objects could be billions of times heavier than our Sun. The total mass of all the stars in one galaxy might be 100 billion times heavier than our Sun. Does the thought of trying to comprehend something so immense give you chills? Even though most galaxies during this period are relatively small and only expanding slightly, some giants mature far more quickly than others. It remains unclear what causes this or how it functions. Penn State University astronomy and astrophysics assistant professor and study co-author Joel Leha expressed his astonishment at the discovery of a new category of objects formed at the Big Bang. The discovery that the formation of massive galaxies began at the very dawn of the universe's history challenges many of our previously held beliefs about the state of science. It seems our discovery is so out of the ordinary that it poses challenges to the scientific community. It casts doubt on the entire scenario of how galaxies formed in the early universe. Much larger than anticipated, describes the objects. All galaxies in the range are considered infants since they are still in the process of formation. However, galaxies that are as old as our own have been discovered in the early cosmos, which was previously thought to be its beginning. Spectrometry, which disperses light into its constituent wavelengths to enable more accurate distance measurements, is still required to validate the results, which have scientists scratching their heads. There are only a few recently discovered objects for which distance and mass have been confirmed. If the data is accurate, galaxy creation must have been significantly more efficient and rapid than previously thought. The fact that spectra confirmed our standard operating systems-based inferences from the visuals is encouraging. For years, scientists have sought to decipher cosmic history. However, a single piece of equipment may hold the key. Observations of space and time have long fascinated scientists, so it is not surprising that conflicting facts presented by telescopes might lead to confusion. At this point, cosmologist Dr. Katie Mack has chosen to offer her insights into the matter to explain how this could be occurring. She highlighted that the JWST has been providing evidence of galaxies that appear to have originated or matured much earlier than what scientists had expected from their models. Do not be concerned though, as Mack pointed out, the telescope is capturing images of galaxies over 13 billion light-years away, and they are somewhat blurred. It seems there hasn't even been enough time since the Big Bang for these massive galaxies to have formed according to the dates that cosmologists have been receiving from the telescope. Many in the field were worried that this casts doubt on various theories, including dark matter and the Big Bang, but we should delve deeper into the evidence to determine for sure. The telescope offers breathtaking views of nearby nebulae but only blurry specks when observing distant galaxies. This discrepancy arises because various colors interact differently with distinct segments of the light spectrum. The Webb telescope can detect light from a source in two primary methods. It may use a spectrograph to disperse light, functioning similarly to a prism, and then assess the intensity of each color. Or it might apply filters that permit only a certain range of colors to pass through. By comparing this data with spectra forecasted for galaxies with similar traits, scientists can determine the galaxy's redshift, which reveals the precise epoch in cosmic history being observed. It appears that many galaxies have an abundance of stars or stars that are unexpectedly young, according to models. This anomaly could be due to several factors. The photometric measurements might be flawed due to calibration issues with the telescope. Alternatively, they might be observing a galaxy cluster that is atypical or examining very small regions of the sky. Another possibility is that galaxy spectrum models designed for nearer galaxies may not be accurate for more distant ones. Conversely, if these galaxies are exceptionally large and earlier predictions were mistaken, cosmologists might need to radically revise their theories of cosmic evolution. This isn't the only area where scientists have faced challenges despite technological progress. The discovery of planets that are larger than theoretically possible has puzzled experts, with the most notable being a planet deemed too massive to exist. This has led to a reassessment of our understanding of planet formation and solar system structure, as well as the models crafted by astronomers. Recently, a planet with a mass 13 times that of Earth was discovered by Penn State researchers. Allegedly, this planet is part of a planetary system orbiting the ultra-cool star LHS 354, which is 9 times less massive than our Sun. Before this discovery, scientists did not consider such a scenario plausible. Yet new evidence reveals that the largest planet in our solar system is orbiting one of the smallest and coolest stars, an ultra-cool dwarf. This finding highlights how much we still have to learn about the universe. A planet of this mass orbiting a star with such low mass challenges our expectations. These stars might have formed from enormous gas and dust clouds, with planets emerging from the residual material in the surrounding disk. However, the planet-forming disk around the low-mass star LHS 354 is not thought to contain sufficient solid mass to produce this planet. Its existence forces us to re-evaluate our theories about stellar and planetary formation. An analogy would be comparing stars to a campfire to stay warm. As the fire cools, you must move closer. Similarly, planets need to be nearer to cooler stars to maintain temperatures suitable for liquid water. If a planet orbits closely enough around an ultra-cool star, we can detect its gravitational effect on the star's light or spectra, causing a slight shift in the star's color. In another development, a new awe-inspiring image of the ice giant Uranus, showcasing almost all of its faint rings that were previously difficult to capture, has been obtained by the James Webb Space Telescope. For the dimmer rings, which had only been observed by the Voyager 2 and W.M. Keck Observatory on the Mauna Kea spacecraft before, the image is a remarkable demonstration of the telescope's sensitivity. Uranus, located 1.8 billion miles from the Sun, has 13 known rings, with 11 visible in the new Webb Space Telescope image. Unlike Saturn's horizontal rings, Uranus's tilted orientation makes its rings appear vertical. The two outer rings were not discovered until the 1986 Voyager 2 flyby due to their dusty nature, which made them less visible and harder to photograph. The 9 primary rings were known prior to this. In 2007, images from the NASA Hubble Space Telescope revealed 2 more faint rings orbiting Uranus, further extending the planet's mysterious nature. Although it may appear like the Hubble image only shows the planet in blue, it is actually a false color depiction. The Webb Space Telescope camera collects infrared wavelengths that the human eye cannot detect, so the light is then transformed into hues we can observe. Uranus's north pole is facing the sun due to its 90-degree tilt, and summer is now occurring in that hemisphere. As Uranus completes a full orbit every 84 years, the south pole will not be in sunlight until 2049. A bright haze is present at the planet's pole, suggesting a thickening in the atmosphere's composition. One theory posits that Uranus's moons may have been responsible for capturing the particles around Uranus, thereby forming the rings. Webb's near-infrared camera also observed many of Uranus's 27 icy moons, with some of the larger ones visible in the new images. In a similar vein, the James Webb Space Telescope has made strides in exploring another ice giant, Neptune. The photograph taken of Neptune's rings marks the first such image since Voyager 2 passed by the planet in 1989. 7 of the planet's 14 known moons were also visible. The most luminous feature in the image is the large moon Triton, which outshines the planet. Triton's brightness comes from the frozen nitrogen that covers its surface, and the infrared camera captures a striking image of the moon. According to scientists, it may have initially been a part of the Kuiper belt and was captured by Neptune's gravity. The discovery of Neptune's dimmer rings demonstrates how much more the telescope can capture in comparison to previous efforts. The observatory's technology has ushered in a new era of astronomy, leading to unexpected surprises as its many sensors uncover previously unseen aspects of the universe.